Hi, Sharon Sarago here, and today we're going to talk about counting rules. A problem that asks you to find the number of ways to select or arrange items involves the principles of counting. The fundamental counting principle states that if event A can occur X different ways and an independent event B can occur Y different ways, then the number of ways in which both A and B can occur is X times Y, or X times Y the way that we write it mathematically. For example, if you go to a buffet for lunch and have 5 salad choices and 3 soup choices, then the number of different lunch possibilities would be 5 for the salad choices and 3 for the 3 soup choices. Then you just multiply those together. 5 times 3 is 15. You might remember learning about permutations and combinations in your math classes. A permutation is a selection where the order matters. A permutation is also called an arrangement. To find the number of possible permutation of items, think about the possible number of choices for each selection to be made. For example, suppose that we needed to arrange 5 children for a photo. Does the order matter here? Well, would the photo be identical if the kids switched places? Absolutely not. So consider the number of spots to fill and the number of choices for each spot. If there are 5 children, then we have 5 choices for the first spot in the line. For the next spot, there are now only 4 choices. 5 kids minus 1 already chosen leaves us 4 to choose from. As we fill in the spots, the number of choices is decreasing because the number of kids left to choose from is decreasing. So here, if we had 5 choices right here, we would write our 5. And then the next blank, we've already used one of those 5 choices, so we only have 4 choices. And now we've used 2 of them, so we only have 3, and so on and so forth. So by the time we finish, we would have 5 times 4 times 3 times 1, or multiply all those together, and that is 120 different arrangements of the 5 children in the photo. Let me get rid of those numbers here. Another example. 3 of the digits, 2, 3, 4, and 5, are to be arranged to form a 3-digit number where no digit can be repeated. How many numbers can be created? The first thing that we want to do is set up our blanks for the 3 digits that we're looking for. And then we know that these are our numbers that we can choose from, 1, 2, 3, 4 numbers. So since there are 4 choices, any one of those numbers would fit in there. We would put the number 4 there. And for the second spot, there are 3 numbers left to choose from. We've already chosen 1. So we would put 3 in the next plot. And then finally, for the last spot, there are only 2 numbers left to choose from. So we would put a 2. And then, of course, 4 times 3 times 2 is 24 possible numbers that could be formed from that. A combination is a selection in which the order makes absolutely no difference. For example, pretend that you have 5 children and you need to select 2 of them to be hall monitors. You have 5 choices for the first child to be picked, and then 4 choices for the second child picked. Following the reason above, there would be 5 times 4, or 20 ways to choose the 2. Now, let's say that Fred and Betty are the 2 chosen. Would it matter if Betty were chosen first and then Fred instead of the other way around? In this case, the order doesn't matter, just the selection. So the choice of Betty, then Fred, is the same result as the choice of Fred, then Betty. These 2 are actually the same selection, so we need to divide the number of ways they can be chosen by 2. Because when we put 5 and 4, we're talking about every single possibility, which would include bed Freddie or Freddie in bed. And since we have two of them there, we just want to divide those so that the number of ways for a pair to be chosen from the children would be 5 times 4 divided by 2, and that would give us the answer 10. Here's another example. 2 students will be chosen from a class of 15 students to represent the class for student council. How many different pairs of students can be selected? First of all, we know that we're having 2 students, so we want to put our 2 blanks there. We know that there are 15 students that we could choose from. So for the first student, we would have 15 choices. Then there would be 14 remaining students for the second position. And when we multiply those together, we get 210 possible arrangements. Again, however, each pair could be chosen 2 different ways. So I could have had the person for 14 come first and the person for 15 come second. So, for instance, Sam and Fred would be the same as Sam and Fred, would be the same as Fred and Sam. So I have to take the 210 possibilities and divide by 2 to get 100 in different pairs, 105 different pairs. Let's look at some practice problems. The Snack Shack sells 5 different kinds of chips and 4 kinds of soda. We want to know how many possible soda and chip combinations are possible. So first of all, since there's only 2 things that we're looking at, chips and soda, we put our 2 blanks down. And then we want to know, out of the 5 kind of chips, how many possibilities are there? There's 5. How many possibilities are there for the sodas? We had 4 sodas, so there would be 5. And then 5 times 4, of course, would give us our 20, which would be choice C. Next, a computer password is composed of 4 letters with no letter used more than once. If the first 2 letters are WS, how many such passwords exist? Now you can see that I highlighted letters here. Can you think why? Because we have to know that there are 26 letters in our alphabet in order to do this. So the first thing that we want to do is put our 4 blanks, because we know our password has 4 different letters. And the second thing is, they said that the first 2 letters are WS, so we want to fill that in. That's already taken care of. We can't do anything with it. But now, what are we going to do with this third blank? You know that there's 26 letters. We just took 1 away for the W and 1 away for the S, so that means we would have 24 possibilities left for this blank, and of course 23 possibilities left for that blank. And so when you multiply 24 times 23, you're going to get 552, which is choice D. The 5 seniors in a drama class are competing for 3 parts in a play. If one senior, Brad, is guaranteed the lead, how many ways could the other 2 parts be assigned? First of all, we're going to want to put our blanks down. We're looking for 3 parts in a play, so I have 3 blanks. And then it says Brad is guaranteed the lead. So I want to put him down because now I don't have to worry about him. Well, there were 5 of them that were competing. If Brad has already been chosen, then I only have 4 left to choose from. And then for my last part, I would have 3 to choose from. So that would be 12 different parts. Here we see a group of 3 high school dancers will perform for the pep rally. The group will be made up of 2 expert dancers and 1 novice. If the dance squad contains 10 expert dancers and 3 novices, how many different pep rally groups are possible? Alright, again, the first thing I want to do is always put my dashes down so I know how many I'm looking for. It said there were going to be 3 high school dancers. It would be made up of 2 expert dancers, so I need to identify that. So my expert dancers are going to be those first 2 blanks, and I had 10 to choose from. And then this last blank here was going to be a novice. All right, so let's go back over here and see. The first blank for my expert dancers could be 10, and then the second one could be 9. Now, my novice dancers, how many did I have? 3. And so there would be 3 choices for that. So if I multiplied those all together, I'm going to get 10 times 9 is 90, times 3 is 270. But again, if I said like maybe Sally was for this first blank and then Fred was the second blank, I could have turned them around and had Fred chosen first and Sally. So this number includes all possibilities. And so the fact that that pair is in there, it was actually counted twice. So to get the real number of possible groups that I could have, this pair has to be accounted for. So I'd take that figure, 270, divide it by 2, and I would have actually 135 different possible groups. How many ways can 4 different chairs be arranged in a row so that the tallest chair is located at one end? All right, first of all, let's put our 4 blanks down because we're looking for 4 different chairs. Oh, and then they said the tallest was going to be at one end. Well, I have to always do the exceptions first. So if I know that my tallest is going to be perhaps at this end, and I only had 4 to choose from, then my next numbers would be 3, 2, and 1. However, what if I had my tallest at the other end? So I'm going to have to put in 4 additional blanks, and my tallest is going to be at the back end now, and so these blanks still would be 3, 2, 1, and my tallest. So now we have to multiply that. 3 times 2 is 6, times 1, still 6, times 3 times 2 is 6. Well, actually, it's not a times, it's a plus here, because I have this set plus this set. So 6 and 6 is 12. 12 possibilities for those if my tallest chair was either at this end or at that end. Okay? Sam lost the slip of paper with his locker combination. He remembers that the combination had 3 numbers, all odd. Now I put this in red. When you see something like this, it's a good idea to circle it while you read it. And the first number is a single digit. Same thing right here. He also remembers that the largest number was 35. What is the maximum number of combinations that Sam would have to try? Okay, so I've got 3 digits for his locker combination right here. He said that they were all odd and the first number was a single digit. All right, well, if the first number is a single digit and it's odd, I only have 1, 2, 3, 4, 5 choices for that. All odd, single digit. So I can put my 5 right there. And then he said that the largest number was 35. So let's go ahead and put that in. Now I'm putting a parenthesis around it so that I'll remember this is not for me to multiply. This is the actual number. So I don't do anything with it. But I do have to account for the fact that I've just used one of the numbers. And then he said the largest number was 35, so I need to know how many odd numbers there are from 1 up to 35 so I can figure out what that would be. So I've listed them down here, starting with 1, going up to 35. Well, there are 18 of those numbers. However, I've already used one of these, so I have to subtract that one. And I've already used the 35 here, so I have to subtract another one. So there's actually only 16 possibilities for this last blank. However, let's look at this. This is one combination, but what if I had my 35 over here? So then I would still have, well, I put my 35 at the end instead of here, but I would still have the 16 that I had here, and I would still have the 5 that I had here. Everything remains the same except the placement of this 35. But when I do that, I've come up with 2 sets of numbers. So when I multiply 5 times 16, I get 80 if my 35 was the middle number. And if my 35 were the last number, I would still have 5 times 16, which is 80, which means now I have to add those 2 and I would get 160 total of what combinations. Now, the ones that I've just worked for you are actually on your sheet, but even though I've showed you how to do them, I want you to go back, and when you're doing your exercise, I want you to try them all by yourself. If you can't figure out how to do it, then you can look at the video again and remind yourself. And then there's a bunch of other ones there, and some of them are a little bit difficult, so mark those, and those will be the ones we talk about during our meeting. And I'll have other recordings up pretty quickly, so enjoy the week and enjoy learning all this new stuff. And bye-bye.